On a clear night, far enough from city light, you can see somewhere between 2,000 and 3,000 individual stars with your bare eyes. That number feels large until you learn what it represents. 2,000 stars, 3,000 on a very good night. Out of the 200 billion stars in our galaxy, the human eye, even at its best, even on the darkest night it can find, can resolve roughly 100,000th of 1% of what is actually there. The rest is hidden. Not by clouds, not by distance alone, hidden by the simple limits of what a human eye can gather. And yet the stars that are visible are enough. They have always been enough. Enough to navigate by, to tell time by, to mark the seasons, to anchor a story, to feel, standing outside on a quiet night, that the sky is doing something, that it is not empty, that it has weight and depth and a kind of patient permanence that the daylight world does not. That permanence is real, but it is not simple. That the light arriving at your eye from any given star has been traveling for years, sometimes centuries, sometimes longer. The star you are looking at is not the star as it is right now. It is the star as it was when the light left it, a year ago, 10 years ago, 800 years ago, in the case of some of the brighter points in familiar winter constellations. The sky is not a single moment. It is an accumulation of moments stacked at different depths, arriving at the same instant at the surface of an eye that cannot tell the difference. This is not a difficult thing to understand, but it is a difficult thing to hold. The mind knows it and then releases it, because looking at the sky does not feel like looking at the past. It feels immediate, it feels present. The stars are just there, steady and close enough to name, and the 4 light years between you and the nearest one among them do not register as 4 light years. They register as distance in the way that a mountain across a valley registers as distance, real but crossable in imagination, if not in fact. What is harder to hold, what most people never quite reach, is the structure that all of those stars belong to. The stars you can see on a clear night are not scattered randomly through the galaxy. They are almost entirely local. Almost every point of light your eye can resolve on its own belongs to a specific region of the Milky Way, a region with defined boundaries, a measurable width, an internal architecture that scientists spent decades trying to map from the inside, a region with a name, though most people have never had occasion to use it. It is called the Orion Arm, not the Milky Way, not the solar system. The Orion Arm, the spiral arm of our galaxy that the sun currently moves through. The structure that contains every constellation you have ever learned, every star that any navigator in history has used for a bearing, every nearby stellar system that astronomers have studied in any detail. A structure at least 20,000 light years long and 3,500 light years wide, containing billions of individual stars and enough gas and dust to keep forming new ones for millions of years to come. Tonight, this is where we are going. Not outward to distant galaxies, or across the full span of the Milky Way. Into the arm, into the structure that is already here, already surrounding us completely, already holding every familiar point of light. There is something quietly strange about traveling towards something you are already inside. The arm does not announce itself. You cannot point to its edge from the ground. You cannot sense its shape because you are part of it, the way you cannot see the shape of a valley, while standing in the middle of it, looking at one slope, then the other, with no view from above. But the arm is there. It has always been there. And when you look up at any star on any clear night, Sirius, burning low in winter, or the steady cluster of the Pleiades in autumn, or the faint powdering of the Milky Way's disk on the best summer nights, you are looking at a piece of it. You are looking at home, not the small, immediate home of the solar system, the larger one, the one that holds the solar system the way a forest holds a single clearing, so completely that from inside the clearing, the forest seems to extend without limit in every direction. That is where we begin, in the clearing, looking out, before any astronomer named the arm, before any telescope was pointed at the sky, before anyone had reason to suspect that the stars formed patterns at a scale larger than the constellations themselves. People needed the stars, not philosophically. Practically, a sailor crossing open water without landmarks Without instruments, without any fixed reference except the sky above and the ocean below, needed the stars the way you need a road in the dark. Not as a subject of contemplation, but as a tool for survival. The stars that held steady in their rising and setting positions gave bearing. The ones that marked the zenith gave latitude. The entire overhead architecture of the night was a working system, learned over generations, passed down through practice and repetition, as precise in its application as any modern navigation chart. Sailors, because crossing the Pacific, used this for 1,000 years or more. The Pacific Ocean is the largest surface feature on Earth. It covers more area than all the land masses combined. Crossing it in a wooden vessel, reading nothing but the sky and the feel of the swell beneath the hull, required a relationship with the stars that most people today have no reference for. The navigators who did it, Polynesian, Micronesian, across traditions that varied by island group and lineage, did not experience the stars as distant or abstract. They experienced them as neighbors, reliable ones, the kind you build your plans around, because they have never once failed to appear. Certain stars mattered more than others for that work. The ones that rose and set at useful bearings, the ones bright enough to track through thin cloud, the ones steady enough that a slightly tired eye could still find them. The stars that held those qualities were not selected by any single person. They were selected by centuries of trial, by the accumulated experience of people crossing open water and arriving or not arriving on the other side. The familiar stars you know by name: Sirius, the brightest in the sky; Vega, directly overhead in summer for northern observers; the stars of Orion's belt, rising in winter with a reliability that made them useful for timekeeping long before anyone had a clock. All of them are inside the Orion Arm, every one of them. The navigators who depended on them were navigating inside the arm without knowing the arm existed. Ancient Egypt mapped stars from rooftops. Scribes recorded their rising and setting dates as a kind of calendar, timing the flooding of the Nile to the first appearance of Sirius before dawn. The star they called Sopdet, the one we call Sirius, was not merely a point of light. It was a signal, an announcement, the beginning of a new year, marked not by a number on a page, but by a specific light appearing at a specific place in the sky, at a specific time of morning. That same star is 8.5 light years from Earth. The light a scribe in Memphis recorded arriving had left Sirius 8.5 years before it crossed the threshold of a human eye. The scribe did not know this. It did not matter. The star performed its function, announced the flood, marked the season, held its position, without requiring any understanding of what it was. This is the thing about the arm that takes a moment to absorb: the structure that contains our sun, that contains every star any civilization has ever named, that forms the largest geographical fact of our immediate galactic environment. This structure was completely invisible to human awareness for the vast majority of human history, not because it was hidden in any meaningful sense, because no one had yet developed the tools to ask the question its existence would answer. The Big Dipper has been used for navigation across the northern hemisphere for thousands of years. Its two outer stars point toward Polaris, the North Star, which stays nearly fixed above the North Pole as the Earth rotates. Sailors in the northern Atlantic used this alignment on dark nights when compass readings were uncertain. The stars of the Dipper are between 60 and 125 light years from Earth. All of them are inside the arm. Orion's belt, 3 stars in a nearly straight line, crossing the celestial equator, visible from almost every inhabited point on the planet, has appeared in the myths and calendars of cultures on every continent. The Egyptians used it. Cultures across sub-Saharan Africa identified it. Indigenous traditions in Australia and the Americas named it independently. The 3 stars range from roughly 800 to over 1,000 light years away. All of them are inside the arm. Long before any telescope existed, sailors crossing the Pacific used these stars to find their way home. They did not know the mass or temperature of a single one. They knew only that the stars were steady, that they rose at the same bearing season after season, that they held their positions through the hours of a crossing. that they had never once failed to appear when the sky cleared. For 10,000 years, that knowledge was enough. It was everything. There is something worth holding in that, even now. The same arm that holds our sun holds the stars that guided those voyages. The same structure that astronomers are still working to map in full contains every point of light that any human eye in any generation has ever looked up and recognized. The arm did not need to be understood to be useful. It did not need a name or a boundary or a measured length to serve as the ceiling of every civilization that has ever looked skyward. It was there. It has always been there. And tonight, resting here, you are still inside it. The same structure that held Sirius above the Nile. The same arm that stretched overhead above every navigator who found their way home across open water. The lights are quieter now. The sky, if you can see it, holds the same stars, and the arm extends in every direction, patient, enormous, and entirely indifferent to whether it is understood, which it turns out makes it easier to rest in. The Milky Way is a barred spiral galaxy. That phrase appears often enough in popular science that it has lost some of its texture. But the texture is worth recovering, because it is the texture that makes the arm intelligible. A barred spiral galaxy is a disk of stars and gas organized into sweeping curved structures, arms, that wind outward from a dense central region shaped roughly like an elongated bar. The disk is thin relative to its width, the way a coin is thin relative to its diameter. From above, it would look like a slow pinwheel, its arms traced by the brightest stars and the warmest gas, the spaces between them quieter, less populated, a little darker. Our galaxy contains somewhere between 200 billion and 400 billion stars distributed across this disk. The disk spans roughly 100,000 light-years from edge to edge. It rotates, not rigidly, the way a wheel rotates, but differentially, with the inner parts completing their orbits faster than the outer ones. And within it, the stars and gas do not spread evenly. They pile up along the arms. The Milky Way has two dominant arms, the Perseus arm, which lies farther from the galactic center than we are, and the Scutum Centaurus arm, which wraps closer to the core. Between and alongside these run several additional features: the Sagittarius arm, inward from our position, the Norma arm, farther in still, and then there is the arm the solar system currently occupies. It sits between the Sagittarius arm on one side and the Perseus arm on the other, not at the galactic center, not at the outer edge. Somewhere in the middle of the disk, roughly 26,000 light-years from the core, in a region that feels neither particularly crowded nor particularly empty by galactic standards, an ordinary location in an ordinary part of an ordinary spiral galaxy. The arm that holds our sun runs roughly from the direction of the constellation Cygnus, at one end toward the constellation Carina at the other. A long, slightly diagonal sweep across our portion of the galactic disk, at least 20,000 light-years from end to end, roughly 3,500 light-years wide. Our sun sits near the inner edge of this arm, slightly off-center, not at the arm's thickest point, but not at its thinnest either, somewhere in the arm's middle section tucked against its inward rim. But the sun does not sit directly in the arm's densest gas. It sits in a small region where the gas is thinner than the surrounding material, a cavity. Astronomers call it the local bubble. Roughly 14 million years ago, a cluster of massive stars in the nearby Scorpius Centaurus region reached the ends of their short lives and detonated, several supernovae in sequence. The explosions blasted the surrounding interstellar gas outward, carving a cavity in the arm's material, a region where the gas density dropped dramatically, where the temperature of the remaining thin gas climbed to nearly 1,000,000 degrees, where the usual crowding of the interstellar medium gave way to something quieter and more open. The cavity they made is roughly 1,000 light-years across. Our solar system drifts through it. Think of the arm as a forest, not a tidy, managed forest with clear paths and regular spacing between trees. A real one, with dense groves in some places, open clearings in others, thickets of young growth where recent disturbances let light in, mature stands where trees have been growing for millions of years. The densest parts of this forest are the molecular clouds, enormous concentrations of cold gas where stars form. The clearings are places where past stellar explosions have blown the gas outward, leaving behind a warmer, thinner space before the forest slowly fills back in. The local bubble is a clearing in that forest, 1,000 light years across. That number is almost beyond ordinary reckoning. Light, moving at 186,000 miles per second, requires a full millennium to cross it. And yet in the context of the arm, it is a small thing. You could fit dozens of local bubbles side by side across the arm's width. You could line up hundreds along its length. The clearing that contains our sun, the region that holds every star visible to the naked eye from Earth, every constellation that any human culture has ever named, is a modest pocket inside a structure that extends thousands of lights beyond it in every direction. This is the first real confrontation with the arm's scale. Not the arm against the galaxies or the galaxy against the cosmos, just the arm against the thing we call our local neighborhood. The bubble is vast, the arm dwarfs it. Right now, drifting through this clearing, you are inside both. The bubble's walls, the denser gas where the arm reasserts itself, are several hundred light years away in most directions. Beyond those walls, the arm continues. Its molecular clouds accumulate cold gas, its young stars burn blue and brief. Its interstellar medium carries the residue of every stellar death that has happened inside it across billions of years. The solar system moves through this clearing on its orbit, around the galactic center, at a speed of roughly 720,000 kilometers per hour. That sounds fast. Against the scale of the arm, it is slow. Slow enough that the sun has been inside the local bubble for millions of years, and will likely remain inside it for millions more before its orbit carries it into denser material. For now, the clearing holds. The arm's nearest gas, the beginning of the forest beyond the meadow's edge, lies close enough that the stars forming inside it are visible to the naked eye. The Orion Nebula, a stellar nursery where new suns are igniting from collapsing gas right now, sits roughly 1,300 light years from Earth. The Pleiades cluster, that small tight arrangement of blue-white stars visible in autumn, formed from a dense cloud inside the arm roughly 100 million years ago, and has been dispersing slowly through the arm's interior ever since. All of it is just beyond the bubble's walls, the next part of the forest beginning where the clearing ends. And from this clearing, everything looks manageable. The sky seems finite, the stars seem countable. The arm, if you have never thought about it, seems like background, scenery rather than structure. But the arm does not stop at the edge of the bubble. It does not stop at the edge of what the eye can see. It extends outward in every direction, for thousands of light years beyond the last star any naked eye has ever resolved. The narrative engine of tonight's journey is this. We begin here, in the clearing, where things are familiar, and then we walk outward, into the forest, into the arm's interior where the scale changes, where the structures become more than scenery, where the arm reveals itself not as a label on a diagram but as a living, breathing, dynamic environment with a history older than any planet and a future longer than anything a human mind can comfortably hold. We are just beginning to walk. The arm's interior is not empty space studded with occasional stars. It is a landscape, a dense, layered, dynamic environment where molecular gas piles up into enormous cold clouds, where those clouds collapse under their own gravity over millions of years and ignite into stars, where those stars burn through their fuel and die, seeding the surrounding gas with the elements they manufactured in their cores, and where the cycle begins again. By galactic standards, the Orion Arm is not a quiet region. It is one of the more active star-forming environments in our part of the Milky Way. The nearest major example is also the most famous. The Orion Nebula sits roughly 1,340 light-years from Earth, just beyond the arm's nearest dense gas. It is a stellar nursery, a cloud of gas and dust spanning approximately 24 light-years across, illuminated from within by a tight cluster of hot young stars called the trapezium, whose intense ultraviolet radiation has carved a cavity in the surrounding material and set the whole structure glowing in visible light. The nebula is not an object in the way that a planet or a comet is an object. It is a process, an ongoing, continuous act of stellar birth happening across its entire volume, with new stars collapsing out of dense cores buried in its coldest regions even now as you listen. The Orion Nebula is not the whole picture. It is the visible face of a much larger structure called the Orion Molecular Cloud Complex, a system of cold gas spanning roughly 240 light-years from one end to the other, containing approximately 200,000 solar masses worth of material. The nebula is the brightest part, the part that a telescope or even binoculars can reveal, but the complex itself is far larger, a thick concentration of molecular hydrogen, quiet and dark, except where the young stars within it have begun to heat and ionize the surrounding gas. Farther along the arm, in the direction of the constellation Cygnus, lies a region so massive and so prolific that it rivals anything in the neighboring spiral arms. The Cygnus X complex sits roughly 4,600 light-years from Earth, near one end of the arm's measured extent. It contains some of the most massive and luminous stars known anywhere. Blue hypergiants burning at temperatures that make our sun seem modest, embedded in molecular clouds that stretch across hundreds of light-years. For years, astronomers debated whether Cygnus X belonged to the Orion Arm at all, or whether it was part of the more distant Perseus Arm just beyond. Direct distance measurements using radio interferometry settled the question. Cygnus X is inside the Orion Arm. It belongs to our structure, and its presence extended the arm's known reach considerably beyond what earlier surveys had assumed. In the other direction, closer to the Sun, quieter but no less active, the Taurus molecular cloud sits about 440 light-years away, cold, dark, studded with newly forming stars so young they are still embedded in the gas that made them. Then the Perseus molecular cloud, farther out, another dense complex where stars are forming. Then the Cepheus cloud, then Chameleon, Lupus, Ophiuchus, a chain of star-forming regions scattered through the arm's interior, each one a site of active creation, each one a part of the larger structure we have been slowly walking through. And then, in 2020, something changed about how we understood these regions. A team of astronomers used three-dimensional dust mapping, precise distance measurements from the Gaia spacecraft, combined with data on how much dust lay at each distance along every line of sight, and found something that no two-dimensional survey had ever revealed. The individual star-forming regions scattered across the arm's interior were not scattered. They were connected into a single structure 9,000 light-years long, running through the arm like a spine. They named it the Radcliffe Wave. The wave threads through the Orion Arm in a continuous ribbon, linking the Orion molecular cloud complex to the Taurus clouds, then to Perseus, then to Cepheus, then to the Cygnus complex, then beyond. A chain of dense gas and stellar nurseries strung together across a length of 9,000 light-years, oscillating gently above and below the galactic midplane as it runs. In some places the wave rises 500 light-years above the disk, in others it dips below. The shape is sinusoidal, a slow, enormous undulation through the arm's interior, continuous from one end to the other. For all the years that astronomers had studied the Orion Nebula and the Taurus clouds and the Perseus region as separate objects, the wave had been there, hidden not because it was faint, but because without accurate three-dimensional distances, its individual components appeared scattered across the sky with no visible connection. The third dimension was missing. Once Gaia's distance measurements provided it, the pattern appeared immediately. A structure 9,000 light-years long, hidden in plain sight, discovered in 2020. In 2024, a second discovery followed, using updated Gaia data to track the motions of young star clusters born within the wave's gas clouds. Researchers demonstrated that the Radcliffe Wave is not merely wave-shaped. It moves like a wave. The entire 9,000 light-year structure is rising and falling through the galactic plane over time. A wave moves through water, each section rising and falling in sequence as the disturbance propagates along its length. It ripples, it breathes, On timescales of millions of years, the arm's interior spine is in motion. No one knows what set it oscillating. Some researchers have proposed a past collision with a massive gas cloud or a dark matter substructure passing through the disk. The initial disturbance has not been identified. What is clear is that the result, a 9,000 light-year wave of gas rippling through the arm, giving birth to new stars along its entire length, is one of the most significant structures discovered in our galactic neighborhood in recent decades. And then, in early 2025, the wave came closer. A study published in the journal Astronomy and Astrophysics showed that the solar system did not merely drift near the Radcliffe Wave, it passed through it. Sometime roughly 12 to 15 million years ago, the Sun's orbit around the galaxy carried the entire solar system through the dense gas of the wave's Orion region. The encounter likely lasted several million years. During that time, the solar system was immersed in the denser interstellar environment of the arm's interior, a place where molecular gas concentrations are higher, where stellar activity is more intense, where the heliosphere would have been compressed closer to the planets than it normally reaches. The arm did not merely surround the solar system during that passage. It reached in ancient Egypt. A scribe recording the stars from a rooftop in Memphis could look up at the same band of soft light crossing the summer sky and see the same stars that mark the Radcliffe Wave's nearest reaches. He had no name for the wave. He had no concept of the arm. The light from the Orion Nebula, 1,300 light-years away, had been traveling for over a millennium before it arrived at his eye, and the connection between that glow and the molecular cloud in Taurus, 400 light-years in the other direction, had not yet been imagined by anyone. The arm held both. The wave ran between them. The geometry was already there, waiting to be discovered. 12 to 15 million years ago, the solar system was inside the densest part of it. 12 to 15 million years ago, there were no humans to notice. This is what the arm contains, not scattered objects but connected architecture. 9,000 light-years of oscillating gas and newborn stars, whose individual components were studied in isolation for generations before the pattern running through all of them was finally seen. The arm is not a backdrop. It is a layered environment with a structure complex enough that a civilization with space, telescopes, and continent-spanning radio arrays only mapped its spine 5 years ago. Consider what that means for what we do not yet see. The Radcliffe Wave is the most dramatic recent discovery in our local arm, but it is not the only large-scale feature inside it. The arm contains vast complexes of molecular gas in regions that no instrument has yet mapped with the same three-dimensional precision. Its far reaches toward Carina in the southern sky remain poorly constrained. Major star-forming complexes may exist in the arm's more distant regions that have not yet been identified. The arm we think we know may be even larger, even more architecturally complex than current data reveals. The part of the arm nearest to the Sun has been studied with increasing precision for a century. It has molecular clouds, stellar nurseries, a 9,000 light-year wave rippling through its interior. It has stellar clusters and OB associations, loose groupings of hot young massive stars born together from the same collapsing gas and still moving through space as coherent groups. The Scorpius-Centaurus Association, the one whose supernovae carved the local bubble, spans roughly 400 light-years across. The Orion OB1 Association, centered on the familiar constellation, stretches across a similar distance. Each of these is a significant substructure. Each one represents a region of intense stellar activity, a place where massive stars formed and died and reshaped the surrounding gas over millions of years. And each one is a small room inside a building that extends far beyond any single room. The arm holds all of them simultaneously. It has room for all of them simultaneously, and it has room for vastly more that remains unmapped. Red dwarf stars, small, cool, dim, representing roughly 70% of all stars in the Milky Way, fill the arm's volume in numbers that no survey has fully captured. The nearest one, Proxima Centauri, is invisible to the naked eye, despite being only 4 light-years from the Sun. The arm contains billions of them, unknown individually, burning steadily, many of them surrounded by planets that have never been detected, orbiting inside a structure that the civilization on the one confirmed inhabited planet in the Arm only recently learned to name. Tonight, the Arm is quiet. Its molecular clouds are cold and dark in the spaces between the star-forming regions, accumulating potential slowly, waiting for gravity to win the argument against thermal pressure that has been ongoing for millions of years. Somewhere inside it, right now, a star is forming. Somewhere else, a massive star is approaching the end of its fuel and beginning the slow expansion that will end in an explosion. The Arm does not pause. It does not rest. It simply continues. For most of human history, no one knew the Arm was there. Not because they were not looking. They were looking constantly, with more care and more patience than most modern people apply to the sky. But looking at stars from inside the Arm and understanding the Arm's shape are fundamentally different activities. The first is available to anyone with a clear night. The second requires measuring distances to objects thousands of light years away and assembling those distances into a coherent picture. And for most of history, no one had a reliable way to do either. The first serious evidence that our local stars trace a real galactic structure came in December of 1951. An astronomer named W. Morgan, working at Yerkes Observatory in Wisconsin, presented something unusual at a scientific meeting. Not a graph or a photograph. A wooden board roughly the size of a tabletop, into which he had driven 25 small nails. At the top of each nail sat a cotton ball. Each cotton ball represented the measured position of a grouping of hot, massive, young stars, whose distances Morgan and his colleagues had calculated. When the audience looked at the board, the cotton balls were not scattered randomly. They fell into 3 distinct linear groupings, 3 parallel bands stretching across the portion of the sky Morgan had studied. He told the room they were looking at 3 spiral arms of the Milky Way. The nearest band, the one containing our sun, would eventually be named the Orion Arm. The room, by several accounts, erupted. For the first time in history, someone had demonstrated observational evidence of spiral structure in the Milky Way. It had been proposed theoretically for decades. 25 cotton balls, placed according to actual measured distances, made it visible. It was crude. 25 data points for a structure spanning tens of thousands of light years. But it was the beginning. The decades that followed brought better tools. Radio telescopes, which could detect the characteristic emission of neutral hydrogen gas at a wavelength of 21 centimeters, could see through the dust that blocked optical surveys. Dust absorbs visible light, making stars beyond a few thousand light years largely invisible to optical instruments. But radio waves at 21 centimeters pass through interstellar dust as if it were not there. Radio surveys could, in principle, map the Arm's gas across its full extent, not just the nearest visible portion. In practice, this turned out to be harder than it sounds. Converting a gas cloud's radio velocity into a distance requires assumptions about how the galaxy rotates, and those assumptions introduced large uncertainties. The maps were blurry. Different research groups produced different Arm models. Progress was real but slow. What astronomers needed were direct geometric distance measurements to objects embedded deep inside the Arm, not velocities converted to distances through models. Actual distances, measured with the same geometric precision that surveyors use on the ground, where you measure the angle to something from 2 different positions and calculate the distance from the angle and the baseline between your 2 viewing points. In astronomy, this technique is called parallax, and for nearby stars, optical telescopes have used it for over a century. But for objects thousands of light years away, the parallax angles become too small for optical instruments to detect. This is where masers changed everything. A maser is the microwave equivalent of a laser, a natural source of intense, narrow-beam microwave emission found inside regions of massive star formation throughout the galaxy. Maser spots are compact enough that radio interferometry, using arrays of telescopes spread across continental distances, can pinpoint their positions on the sky with extraordinary precision. That precision applied to observations of the same maser from opposite sides of Earth's orbit around the Sun, yields a parallax measurement, a direct geometric distance, requiring no assumptions about galactic rotation. In 2013, a team led by researchers at the Purple Mountain Observatory in China used very long baseline radio interferometry to measure precise distances to maser sources associated with star-forming regions inside the Orion Arm. What they found pushed the arm's measured length far beyond what previous surveys had shown. Regions that velocity-based methods had placed in the more distant Perseus Arm turned out to be much closer, sitting squarely inside the Orion Arm. The arm was longer than anyone had assumed. Its pitch angle and star formation rate were comparable to the galaxy's recognized major arms. By 2016, the same group had extended the arm's known length to at least 20,000 light-years, more than twice the estimate that older textbooks had carried. The arm was not a minor spur. It was a legitimate, large-scale spectral structure. Then the Gaia spacecraft arrived. Launched by the European Space Agency in 2013, Gaia spent more than 11 years scanning the sky, measuring the precise positions, distances, and motions of nearly 2 billion stars before completing its observation phase in January 2025. Its data transformed the study of galactic structure in ways that no ground-based survey could match. Not because any single Gaia measurement was more precise than the best maser parallax. It was not. But because Gaia applied its measurements to nearly 2 billion sources simultaneously, providing a statistical picture of the Milky Way's stellar distribution at a scale no previous mission had approached. Multiple independent research teams used Gaia data to trace the distribution of young, hot stars across the disk. Because these massive short-lived stars are born inside spiral arms and die before they can drift far from their birthplaces, their distribution in three-dimensional space traces the arm's shape directly. What the analyses found consistently across different teams using different stellar tracers and different methods was an Orion Arm that stretched across at least 25,000 light-years, longer than any earlier estimate, with properties indistinguishable from the galaxy's traditionally recognized major arms. Every grandmother who ever pointed upward on a summer night, every child who ever asked what the band of light crossing the sky was called, every navigator who ever used a star as a bearing, they were all inside this structure, not near it, inside it. They existed within the arm's body the way a fish exists within a river, surrounded completely with no view of the bank, and none of them knew it was there. The first person who demonstrated that the arm existed did so with a wooden board and 25 nails 70 years ago. The first spacecraft to measure it comprehensively completed its observations 5 months ago. There is something worth resting in about that sequence. The arm is real enough that cotton balls on a board could outline it. It is large enough that a spacecraft measuring 2 billion stars is still working out its full extent. Human observation crossed the distance between those two scales in a single lifetime. Gaia also revealed something more subtle. The arm's boundaries are not clean. The edges between the Orion Arm and the interarm regions on either side are not crisp lines but gradual transitions, zones where stellar density rises and falls, where diagonal spurs and branches connect the arm to its neighbors in ways that complicate any simple diagram. The Milky Way's spiral pattern is messier and more dynamic than the elegant textbook illustrations suggest. The arms are real, but they are ragged. This messiness is itself information. It tells us that the arms are not rigid permanent structures engraved into the galaxy's disk. They are something subtler than that, and understanding what they actually are, what maintains their shape, what drives their motion, requires an idea that, when it was first proposed, seemed almost too strange to be true. We are approaching that idea now. The scale keeps expanding. The arm keeps growing. And the clearer it becomes, the more the question of what it means to live inside it begins to press in from the edges of everything else. The Orion Arm is not our permanent address. This is not a metaphor or an approximation. It is a precise consequence of how spiral arms actually work, what they are physically, what maintains their shape, and what that means for any star currently inside one. In the 1960s, two mathematicians at MIT proposed something that seems counterintuitive at first. Spiral arms, they suggested, are not collections of specific stars moving together through the galaxy. The stars inside the arm are not bound to the arm the way passengers are bound to a train. Instead, the arm is a pattern, a gravitational pattern that rotates through the galaxy's disk at its own speed, separate from the speed of the stars and gas that populate them. The arm is a zone of compression. As the pattern rotates, it squeezes the material it passes through, increasing local density and triggering star formation. Stars enter the compression zone from one side, spend time inside it where conditions are denser and star formation is more active, and eventually drift out the other side, continuing their individual orbits through the lower density inter-arm region until they eventually encounter the next arm. The arm persists. Its inhabitants rotate through. Think of a long line of slow-moving traffic on a highway. The congestion itself stays roughly in place. Individual cars enter from behind, slow down while they are inside the jam, and eventually pass through the front and accelerate again. The traffic jam is not the cars. It is the condition the cars pass through. The cars are not the jam. They carry the jam's shape in the moment they are inside it, and then they leave. Spiral arms work the same way. Our Sun is currently inside the Orion Arm's compression zone. It has been inside it for a long time, long enough that our entire recorded history, our entire species, and several million years of pre-human evolution have all occurred within the arm's borders. But the Sun was not always here, and it will not always remain here. The Sun orbits the center of the Milky Way at roughly 720,000 kilometers per hour. At that speed, one complete orbit takes approximately 225 million years. In the roughly 4.5 billion years since the Sun formed, it has completed about 20 of these orbits. During those 20 orbits, it has drifted through different portions of the galactic disk, entering spiral arms, spending time inside them, exiting into the quieter inter-arm regions, entering the next arm. The arm it currently occupies. This one, the Orion Arm, is a temporary station on a journey that has been continuous for longer than Earth has existed. In approximately 100 million years, the solar system will likely have drifted clear of the Orion Arm's compression zone and into the lower density space between the arm and its neighbors. The stars currently surrounding us will still exist, but they will have moved along their own orbits to different positions. The arm will still exist as a pattern, populated by different stars, many of them not yet born, forming from gas clouds that have not yet collapsed, in stellar nurseries that will not ignite for tens of millions of years. The arm endures. The stars inside it change. In 100 million years, no star currently inside the Orion Arm will be inside it, including ours. This is the timescale at which the arm operates. Not human years, not geological years, but galactic years, each one lasting 225 million Earth years. The arm has been turning through the Milky Way's disk for billions of galactic years. It formed before our Sun existed. It will be here after our Sun has exhausted its hydrogen, expanded into a red giant, shed its outer layers, and faded to a cold white dwarf, drifting through whatever portion of the galaxy its orbit has carried it to by then. The arm is not ours. We are passing through it. Light from one end of the arm to the other takes 20,000 years to travel. The arm itself is so large that its own light cannot cross it within a span longer than all of written human civilization. While that light is crossing, civilizations rise and fall, languages appear and disappear, entire species come into existence and go extinct. The arm is indifferent to all of it. It rotates through the galaxy's disk at the speed that the galaxy's gravitational dynamics require, compressing the gas it encounters, producing the stars the compressed gas makes, continuing with the same patience it has maintained for billions of years. Somewhere inside the arm tonight, a star is forming that will burn for 10 billion years. Long after the Sun has died, that star will still be burning. Its planets, if it has them, will exist long after Earth has been consumed by the Sun's expansion, and the arm, or whatever descendant pattern of the arm, persists across that timescale. will still be turning through the disk, compressing new material, triggering new rounds of star formation in gas clouds that do not yet exist. The universe does not operate on scales that human intuition was built to handle. But there is something in the arm's permanence. Its indifference to the brief passage of any individual star through its compression zone that becomes, at a certain depth of consideration, almost restful rather than alarming. The arm is not hostile to our sun. It is not aware of our sun. It is simply a pattern that continues regardless of what any particular object inside it does, or experiences, or becomes. The sun drifts through it the way a person drifts through a city, shaped by it, embedded in it, but not essential to it. The city continues after the person has passed through. The arm will continue. And somewhere inside it, the Radcliffe Wave is still oscillating, rising and falling through the galactic plane on its million-year timescale, giving birth to stars along its 9,000 light-year length, connecting molecular cloud to molecular cloud in one continuous ribbon of gas and new light. It was oscillating before the sun entered this region of the arm. It will be oscillating long after the sun has left. The light from those new stars is crossing the arm right now. Some of it will reach Earth in 1,000 years, some in 10,000. Some is aimed in a direction that will never bring it near any planet that currently exists, and it will cross the arm's full width and exit into interarm space and continue into the Perseus arm beyond, and no eye will ever receive it. It travels anyway. That is what the arm holds. Not just the stars that are here now, but the light of all the stars that have ever been here, still crossing in every direction, still traveling, indifferent to whether it arrives anywhere at all. There is an assumption that lives inside every generation's relationship with the night sky, so quietly embedded that it has rarely been examined. The assumption goes like this: the sky belongs to us, not in any proprietary sense, in a simpler, more intimate sense. The stars are ours to name. The constellations are ours to inherit. The familiar points of light we grew up under, the ones our parents pointed out, the ones whose patterns we learned as children, are ours in the way that a landscape is ours when we have lived inside it long enough to stop seeing it freshly. The arm does not participate in this assumption. The arm does not know we are here. It does not organize itself around our presence or our perception. The Radcliffe Wave oscillates on million-year timescales without reference to whether anyone is watching. The molecular clouds in Taurus collapse into stars that will burn for billions of years, whether or not any civilization exists to observe them. The arm's star-forming regions, the nurseries where gas and gravity are currently negotiating the birth of suns, have been active since long before our planet formed, and will continue long after every structure humanity has ever built has turned to dust. The sky, it turns out, does not belong to us. We belong to it. Or more precisely, we belong to a small part of it, a clearing inside a forest inside an arm, passing through a compression zone in the galaxy's disk for a duration that the arm itself would not register as meaningful. In some sense, this should be unsettling. In another sense, in the sense that matters for a night like this, it is closer to a relief. We carry so much. The weight of our days, the unfinished things, the conversations that did not go as intended, the worries that have no resolution before morning. And then there is the arm, turning through the galaxy, indifferent, enormous, full of light that will never arrive anywhere, and stars that will never be named, and gas clouds that are collapsing right now into suns that no civilization will ever see. Perhaps the relief is this: the arm requires nothing from us. It does not need our attention. It will not notice our absence. It is simply there as it was there before us, and will be there after us. And we are inside it for this brief window of time, looking out at the stars it contains, breathing air made partly of atoms forged in stars that died inside this arm billions of years ago. The iron in your blood was made in a stellar interior, a star more massive than our sun, burning through its fuel faster than it could sustain, reached the point where fusion stopped producing energy and the core collapsed. In a fraction of a second, that collapse bounced and the star exploded. A supernova, scattering its manufactured elements into the surrounding gas. That gas eventually became part of the cloud that collapsed to form our solar system. The iron that traveled through that chain, from stellar core to supernova, to interstellar gas to solar nebula, to rocky planet, to ocean, to life, to the blood currently circulating through your body, was made inside the Orion Arm. You are not observing the arm from outside. You are made of it. Every child who has ever looked up at a clear night and felt something, not understood it, just felt it, that small and wordless expansion that happens when the sky is dark enough and the stars are bright enough and the day is quiet enough, was feeling the arm without knowing it, feeling the weight of the structure that holds every light they could see without having any framework for what that weight was. The feeling was real. It was just larger than the name they had for it. Wherever you are right now, the arm is around you. Its nearest boundary is several hundred light years away. Its far edge is 20,000 light years in the other direction. You are not near it. You are inside it. And in the particular way that things too large to see can still be felt. The way you feel the weight of the sky on a clear night without being able to see the atmosphere. It is possible to simply rest inside the fact of that. The arm holds. Return for a moment to the sailor, not the concept of a sailor, a specific one. Someone standing at the bow of a double-hulled, voyaging canoe somewhere in the middle of the Pacific at 2 in the morning, in conditions where the horizon is barely distinguishable from the sky, reading the stars with a mind trained through years of practice to extract bearing and latitude from the pattern of light overhead. The canoe has been underway for several weeks. The nearest land is many days still ahead. The entire navigational situation, where the vessel is, where it is going, how far it has come, is held not in any instrument but in a single human mind cross-referenced against the sky. The navigator is using stars that belong to the Orion Arm, not using them in any way that requires knowing this. The arm's existence is not relevant to taking a bearing off a star. The star simply needs to rise at a reliable azimuth, hold steady through the hours of the crossing, and set where it is supposed to set. All the stars that served this function for navigators across 1,000 years of Pacific wayfinding met that requirement because the arm is stable. Its stars do not move significantly relative to each other on any timescale that human generations can observe, and the clearing our solar system drifts through provides a relatively unobstructed view of the arm's contents in most directions. The navigator did not need to know any of this. The arm served its function regardless, and here is what has not changed. The same arm is still here. The same stars still rise at the same bearings relative to Earth's orientation at any given season and latitude. The geometry has not shifted. The light from Sirius that an Egyptian scribe noted rising before dawn in early summer still rises before dawn in early summer, its heliacal appearance marking the same season it marked 4,000 years ago. Because the arm it belongs to, the clearing the sun drifts through, the broad neighborhood of the Milky Way we have always occupied, has not changed in any meaningful way on that timescale. 10,000 years of human navigation, 10,000 years of farming and storytelling, and seasonal calendars built on the behavior of specific stars. 10,000 years of people looking up at the Orion Arm's contents and drawing lines between them, naming them, building meaning into the patterns they perceived. The arm did not require their understanding. It did not adjust itself to be more comprehensible. It simply continued providing what it had always provided, a stable field of light above a small planet, reliable enough to build a calendar on, steady enough to cross an ocean by, permanent enough on human timescales to feel like something that was always there and would always be there. The Radcliffe Wave was oscillating through the arm's interior the whole time. Nobody knew. The local bubble the solar system drifts through was carved by supernova 14 million years ago. Nobody knew. The arm stretched at least 20,000 light years from end to end, containing billions of stars and active stellar nurseries, and a 9,000 light-year spine of connected gas clouds. Nobody knew, and the stars served as navigational references anyway. The arm did its work regardless of whether its structure had been mapped. This is the thing that does not require knowledge to rest in. The arm does not become more present when it is understood. It does not become more real when its boundaries have been measured. It is exactly as real, exactly as present in the mind of a Polynesian wayfinder who knows it as a collection of useful reference points, as it is in the mind of an astronomer who knows it as a spiral arm 20,000 light years long. The light arrives either way. There is something about that, about the persistence of the arm's function regardless of any individual's relationship to it, that carries a quality of steadiness, not comfort in any hollow sense, something more structural than that. The arm was there before any eye looked at it. It will be there long after the last eye that ever does look at it has closed. It does not depend on being observed. It does not require testimony. It is simply the environment, the galactic environment, inside which the solar system happens to be passing through this particular phase of its orbit. And right now, in the small hours, the arm is overhead, not visible as a structure, not visible as anything more than the individual stars that belong to it, scattered across the sky in the patterns that every generation has always found there, but present, surrounding the planet completely, extending thousands of light years in every direction from the clearing the sun currently drifts through. Every person who ever looked up at those stars was looking at the arm's contents without knowing the arm was there. That is still true now. Even knowing the arm exists, even understanding something of its scale and structure and history, looking up at the stars still does not reveal its shape. The forest does not become visible from inside the clearing just because someone has told you the forest is large. But the stars are still there. Note, indifferent. Arriving, the arm holds them the way the ocean holds, the light reflected off its surface, completely, without effort, without caring whether anyone is watching. Tonight, it holds them for you. Somewhere inside the arm tonight, a molecular cloud is accumulating mass. It has been doing this for millions of years, quietly, in the cold dark between the arm's bright star-forming regions, far from any light that any instrument currently pointed at the sky would register as significant. The cloud is cold, near absolute zero, made mostly of hydrogen with traces of other molecules that formed on the surfaces of dust grains over enormous timescales. Gravity is winning its slow argument against the thermal pressure that holds the cloud extended. The collapse has not yet begun. It will begin in the way these things always begin, gradually, and then all at once, in some millions of years, that cloud will be a star. The star will burn for billions of years. If it forms planets, and most such stars do, those planets will orbit it through geological epochs longer than Earth has yet existed. None of it will happen quickly. None of it will be announced. The arm does not mark these events. It simply contains them, the way a forest contains the life inside it, without any of that life being visible from a distance. The arm holds this process running in hundreds of places simultaneously, in Taurus and in Perseus, and in the distant reaches of the Radcliffe Wave, in star-forming complexes that have no name yet, because no instrument has yet resolved them from the general glow of the arm's more distant regions. The arm is not pausing tonight. It is not waiting for morning. It simply continues. The same continuous act of creation and dispersal that it has been performing since long before our sun was born inside it. Farther out, near the arm's edge where the density drops and the interarm space begins, there are stars that no human eye has ever resolved individually. Too faint, too distant, too lost in the combined glow of the millions of stars between them and Earth. They burn anyway. They have been burning for billions of years. Some of them have planets. The light from those planets is crossing the arm right now, moving at 186,000 miles per second, indifferent to whether it will ever arrive anywhere that can receive it. Most of it will not. Most of it will cross the arm's full width and continue into the interarm region and eventually fall into the Perseus arm and be absorbed by the gas there, or continue farther into intergalactic space, into the vast dark between the Milky Way and Andromeda, never arriving at any surface, never illuminating anything. It travels anyway. The arm does not require its light to be useful. It does not require its stars to be named. It does not require the clearing at its inner rim, the bubble where the solar system drifts, to produce anything other than what it has produced, which is a small planet where, for a brief window of geological time, something looked up and wondered what it was all part of. The wondering does not need resolutions tonight. The arm is still turning gently. On a timescale measured in hundreds of millions of years, the solar system drifts along its current orbit. The bubble drifts with it. The stars that feel close and familiar, the ones that any person on any clear night can look up and find without any instrument, are drifting too. Each one on its own path through the arm's compression zone, each one a temporary resident of the same structure, passing through on a schedule, or the galaxy sets. None of them are in a hurry. Somewhere in the southern half of the sky, a warm point of light is rising. It has been rising on the same schedule, from the perspective of any given latitude on Earth, for longer than any civilization has existed to mark its rising. It will continue rising long after every name given to it has passed out of use. The light keeps arriving, the arm holds.